Hi everyone, welcome to lecture 11 of our course Basic to Advanced Level Real Analysis. In this lecture हमारा जो टॉपिक है वो है लिमिट एंड कॉन्टिन्यूटी. दोस्तों हमारा जो एम है इज टू लर्न द होल टॉपिक इन डिटेल्स. सो फुल कोर्स ऑफ द सिलेबस पार्ट 4 में डिवाइडेड है. पार्ट 1, पार्ट 2, पार्ट 3 एंड पार्ट 4. आप लोगों को लेक्चर मिल जाएगा फ्रॉम नेक्स्ट वीक वेडनेसडे एंड सैटरडे एट 7 PM. सो अभी हम लोग पार्ट 1 पे है जहाँ पे हम लोग फंक्शन, रियल नंबर सिस्टम, सीक्वेंस एंड सीरीज कवर कर चुके हैं. अभी हम लोग कॉन्टिन्यूटी स्टार्ट करने जा रहे हैं. द लास्ट लेक्चर विच वॉज लेक्चर 10 हम लोगों ने सीरीज का PYQ डिस्कस किया था फ्रॉम जैम एंड नेट. वहाँ पे हम लोग कंपैरिजन टेस्ट क्या होता है, कंपैरिजन टेस्ट 2 क्या होता है, एब्सोल्यूट कन्वर्जेंस क्या होता है, कंडीशनल कन्वर्जेंस क्या होता है एंड टोटल 10 PYQ डिस्कस किया था. इन टुडे लेक्चर लिमिट एंड कॉन्टिन्यूटी में जो टॉपिक कवर होगा वो है व्हाट आर LHL एंड RHL, लेफ्ट हैंड लिमिट एंड राइट हैंड लिमिट, व्हाट कॉल्ड लिमिट्स, व्हाट आर द कॉन्टिन्यूटी विथ एग्जाम्पल्स एंड आखिर में देखेंगे टाइप ऑफ डिसकंटिन्यूटी. सो जो बुक हम लोगों ने रेफर किया हुआ है वो है स्कीमा फॉर रियल एनालिसिस, मैथमेटिकल एनालिसिस बाय मालिक अरोड़ा एंड बाटले एंड सॉबर्ट. आप लोग नोट डाउनलोड कर सकते हो इस वेबसाइट से www.mathnotespedia.in. जो कुछ भी हम लोग डिस्कस करेंगे आप लोगों को नोट मिल जाएगा इस वेबसाइट से, और आप लोग व्हाट्सएप ग्रुप से भी नोट मिल जाएगा. For any query or doubt, you can email me at mail@mathnotespedia.in. So let's start today's lecture. So the first question is, what is left hand limit? Left hand limit क्या है? Suppose f(x) be a real valued function and a be a real number. Then we call f(x) for x less than a and close to a is the left hand limit of f(x). That means suppose you have a function f(x) and there is a point a. So on the left hand side of a here and close to a, the corresponding value of f(x) will be the left hand value, and we will call that left hand limit of the function f(x). Okay, and we denote this as limit x tends to a minus f(x). Okay, similarly for right hand side, the value of f(x) for x greater than a and close to a is known as the right hand limit. That means a के x राइट में एंड क्लोज टू ए के एकदम निकट में फंक्शन का जो भी वैल्यू होगा वो होगा राइट हैंड लिमिट, एंड वी राइट इट एज RHL is equal to limit x tends to a plus f(x). Okay. Now what is called limit? We call f(x) has a limit L as x tends to a if both LHL and RHL exist and they are equal. If they are equal, then we call the equal value L is the limit of the function f(x), and we write it as lim x tends to a f(x) is equal to L. L is the limit of f(x). Let us consider example. we will find the limit of fx is equal to mod x at x is equal to 0. How can we find that? First, let us find the LHL. Left hand limit क्या होगा? The left hand limit is equal to limit x tends to 0 minus fx. So limit x tends to 0 minus mod x. Now 0 minus means for x less than 0. x 0 के लेफ्ट में fx का वैल्यू क्या होगा? Now you know that for x less than 0, mod x is equal to minus x. So here you will have lim x tends to 0 minus x, and if you put x is equal to 0 here, you will get 0. So here LHL is equal to 0. Okay. Now similarly the RHL will be also 0, because at x limit x tends to 0 plus the value is x greater than 0, and for x greater than 0 that will be limit x tends to 0 plus x, because for x greater than 0 mod x is equal to x, absolute value function. So here if you put x is equal to 0, the limit will be 0. Hence right hand limit is also 0. Therefore, as here LHL is equal to RHL is equal to 0, so we can conclude limit x tends to 0 fx is equal to 0. Okay. Now let us see another example. We will find the limit of fx is equal to mod x by x at x is equal to 0. Okay. So let us first find the LHL, the left hand limit. For limit x tends to 0 minus, that is for x less than 0, you will get mod x is equal to minus x. So here numerator will be minus x. So by cutting you will get minus 1. So LHL is minus 1. Now what is RHL? The RHL is limit x tends to 0 plus fx is equal to x by x, and it will be 1. So observe that here LHL it's not is equal to RHL. Okay. So that's why we can say the limit x tends to 0 fx does not exist. Okay. Now let us see the definition of limit as epsilon delta. The epsilon delta definition says that we will call lim x tends to a fx is equal to L if for any arbitrary epsilon greater than 0 there exists a delta greater than 0 such that mod fx minus L less than epsilon whenever mod x minus a less than delta. Remember that epsilon is our choice, and depending on that epsilon you will get a delta greater than 0, and if you take this neighborhood x minus a less than delta, then you will get fx minus L less than epsilon. If this happens, then we will call this limit x tends to a fx is equal to L. Now let us see this in graphically. Graphically क्या होता है? Suppose this is a function fx, okay, and this is point A. So if you take any neighborhood of A, this is x minus a less than delta, so a minus delta and a plus delta. So if you get a neighborhood fx depending on that delta, okay, then if you find this neighborhood for any epsilon, then you will call the limit exists and equal to that L. Okay, L is the value of the function at that point A. Okay. Now, what is continuity? So, if you know the limit definition, then we can define continuity in this case. Fx is said to be have continuous at x is equal to a if lim x tends to fx is equal to fa. That means here L is the value of the function at the point A. Okay, if this happened, then we will call f is continuous at x is equal to a. कॉन्टिन्यूटी का मीनिंग होता है कि ग्राफ में फंक्शन का कोई भी गैप नहीं होगा. अगर आप कोई भी डोमेन एक ले लेते हो तो अगर ग्राफ ड्रॉ करते हो तो ग्राफ में कॉन्टिन्यूटी होगा. ऐसा नहीं होगा कि ब्रेक हो गया मिडिल में फिर स्टार्ट होगा, ऐसा नहीं होगा. तो ग्राफ एक कॉन्टिन्यूटी विदाउट एनी डिस्ट्रैक्शन द ग्राफ, यू कैन ड्रॉ द ग्राफ. ओके, then we will call the function continuous. Let us see an example. Consider this function fx is equal to sin x by x when x not is equal to 0 and is equal to 0 when x is equal to 0. Now let us find the limit. Lim x tends to 0, fx is equal to sin x by x. Now here at x tends to 0, sin x also goes to 0 and x also goes to 0. So here this is a 0 by 0 form. So you can apply L'Hospital rule. So by applying L'Hospital rule, if you differentiate both numerator and denominator, you will get cos x and x. And x tends to 0, cos x is 1 and sorry यहाँ पे 1 होगा. If you differentiate x, you will get 1. So both numerator and denominator will go to 1, so you will get the limit as 1. Okay, so here lim x tends to 0 fx is equal to 1, but observe that f0 is 0. Okay, as x is equal to 0 पे फंक्शन का वैल्यू 0 है, इसलिए f0 is 0. so lim x tends to 0 fx not is equal to f0. So the function is not continuous. Okay, function is not continuous at x is equal to 0. Now what can we do now? Now if we define the function fx is equal to 1 at x is equal to 0, इसके पहले वाले में हम लोगों ने क्या डिफाइन किया था? हम लोगों ने डिफाइन किया था कि यहाँ पे 0 है. Now instead of 0 you define this value 0 as 1. Okay, 1. Now observe that the limit here x tends to 0 fx is equal to 1 and the value f0 is also 1. So now lim x tends to 0 fx is equal to f0. So we can say this function become continuous at x is equal to 0. So previously this function was not continuous when this value 1 was 0. Now if the value is 1, then the function is continuous. So in the conclusion we can say that the function fx can be converted to a continuous function by just making this 0 is equal to 1. So we have removed the discontinuity. From this, the concept of removal discontinuity has came, which is one type of discontinuity. Okay, so what removal discontinuity says? The removal discontinuity says that if fx be a real valued function, then fx has to be a removal discontinuity at x is equal to a if the limit x tends to fx exists but it not is equal to fa. ठीक है, अगर ऐसा होता है, in that case we will call x is equal to a removable discontinuity. Always remember that by changing the value of fa, like previous example, we can make any removable discontinuity as a point of discontinuity. So that's why the name is removable, as we can remove the discontinuity to continuity. Okay. Now there are another two types of discontinuity. The first is the discontinuity of first kind. So when the function is said to have discontinuity of first kind, if both limit exist, both LHL and RHL limit exist, but they are not equal. In that case, we will call the function has discontinuity of first kind. For example, we have already seen that example fx is equal to mod x by x. Here LHL was 1, here LHL was -1 and RHL was 1. So both LHL and RHL exist, but they are not equal. Hence the function fx has discontinuity of first kind at x is equal to 0. Now what is discontinuity of second kind? The discontinuity of second kind says that if either both or one of the LHL or RHL does not exist, exist ही नहीं करता, LHL or RHL, if either of them or both does not exist, then we will call this discontinuity of second kind. Let us see an example. For example, consider the function fx is equal to 1 by x at x is equal to 0. Then at x tends to 0 minus 1 by x goes to minus infinity, because for x less than 0 and x tends to 0, the 1 by x will goes to minus infinity. Okay, and for x tends to 0 plus, the limit will be infinity. So यहाँ पे प्लस होगा. So the limit both LHL and RHL does not exist. Hence we can conclude that this x is equal to 0 is a removable discontinuity of second kind. Sorry, discontinuity of second kind. So here we have to stop now. In the next lecture we will discuss about the continuity and uniform continuity in details. So till then, goodbye.